Here we go. So we're going to start with number 31. That sound right? Okay. Whoa! All right. Number 31. Everybody's there? Everybody has a book open to page 72, because that's what page it's on. It says a plane lands. Oh, and get your equation sheet out now, so you don't have to worry about it later. And a calculator out now, so you don't have to worry about it later. We're going to be ready to go in 10 seconds. Hustle, hustle, hustle. 5 seconds. 4, 3, moving fast. 2 more seconds. Thomas is going to have to move at the speed of light. Ah! All right. A plane lands with a velocity of 120 meters per second and accelerates at a maximum rate of -6 meters per second squared. So first of all, before we go any further than that, do you understand what's going on?
Yes.
Airplane is traveling this way. The fact that it has negative acceleration means what?
It is slowing down.
Yeah, which is good, right? We don't want it to be landing and speeding up. That would not be a good option.
Then it would crash.
Okay, now, based on the person, I don't know who asked me this. Do you want me to go through A and B?
I just need B.
Just part B, okay. It says, can the plane land on a naval aircraft carrier where the runway is 0.8 kilometers long? So, we'll start with some givens. So take a look at the problem. I want to share the fun of listing givens. So everybody take a look. Raise your hand if you can tell me something that I should write down in the givens list. Brian, what you got?
Initial velocity, 20
Awesome. What else you got? Yeah.
Acceleration is -6
Well, we're doing part B, but we're going to write down the givens from the beginning. Anyway, does that make sense?
Yeah.
Yeah. Zoe, what else? Excellent. Yep.
Based on the results of part A, the time is 20 seconds.
Okay. Okay. And I'm only putting that in parentheses because I generally don't want to have to use something that I just calculated in the next part unless I have to. Does that make sense? Just in case I messed it up. So that's why I put in parentheses, not because I dislike you or something. I just want to make that clear. Right? Oh, don't run away. It'll be okay. All right. Are there any other things that I know or want to know? Yeah. Okay, so now it looks like I've got a whole heck of a lot of stuff, right? What am I trying to find out? What is the question asking, really?
If it can land in that distance.
Yeah, so I think I probably want to solve for D and then compare it to this. Does that make sense? So I'm going to put like a little question mark next to this, even though we wrote that that's what it is. And again, not that we don't like that time, but I don't want to use it unless I have to, just in case I messed it up. But do I have an equation that has these 4 things in it? Take a look at your equation sheet. Everybody look at your equation sheet. Initial velocity, final velocity, acceleration, displacement. Check with your neighbors. See if they agree with you. Are you using the same equations as they are? Take a look.
I guess, then I got it.
Wait, is it, which one is it? This one? That one? Yeah.
No.
Yes.
Why?
Because that's the only one that is
All right. Courtney, what did you guys say back there? You can just read it to me. Read me the equation. Wait, hold on. Read it one more time. Sorry.
Final velocity equals initial velocity plus acceleration times displacement.
Like that? Is there... I feel like you've got the right variables, but I don't think that's in one of the equations. Is it?
No.
Yeah.
I think there are some 2's in there that need to happen. Do you see what I'm saying?
Yeah.
Do you want to tell me which one you think, or do you want to talk to your neighbors real quick? Go ahead and talk to them. you guys make a different decision?
Yeah.
What'd you choose?
Minor velocity squared equals
Yeah.
velocity squared plus 2a.
A times. Love it. Okay. Now, does that make sense to everybody? Okay, cool. So, then you just need to solve this for D and find out if D is greater than or less than 0.8. Or equal to, yeah. Does that get you where you need to go, kind of?
Yeah.
Okay, go ahead.
So for the answer, do we write yes or no? Then?
So, that's a really good question. Whenever you're given a problem that's a yes or no answer problem, I would write yes or no and then say, like, yes, it will stop in da-da-da, or no, it needs, does that make sense?
Yeah.
So that it's obvious that you know what you did. Yeah. So,
Okay, see, I used a different equation. I used D equals initial velocity times time plus 1/2 acceleration times time.
okay, so you can use that, but the trick with that is that that's assuming that your time is correct.
Well, I would hope that I might.
Well, I would too, but here's the thing, Ben, is that if you're taking a test and you don't have the answers to check with, then what if you, instead of typing in, I don't know, whatever the acceleration was, what if you typed it in, like, moving over the decimal by 1? You know what I'm saying? Then this is going to be totally wrong, and then your answer is going to be even crazier wrong. Does that make sense? So I would recommend that you use the thing that doesn't use any other information. But if you did it right, then you will get full credit. You understand what I'm
Would I
saying?
still get the right answer though?
You should, if you did everything right.
2340 meters.
I don't know. What is the answer? Is that the answer? Does somebody agree with that? 31. Part B, the answer should be
Yes.
no.
The answer is
No, the plane needs 1.2 kilometers. So maybe go back through and double check.
I
Okay.
never won, so this is.
Okay.
I'm right.
What's up, babe?
So you don't put in the placement for the
Solve for displacement. Yes. Yes.
That's what I did.
Does that make more sense? Is that okay?
Yeah.
Okay. Yep. All right. Other questions about that question?